How do you feel about using addition? Do we feel okay using addition? Because now I'm going to do the same exact thing, except now we're getting bigger to smaller. Okay? In the givens, it will be bigger. In the proof, it will be in the proof statement, it will be smaller. So we're going to use what's called subtraction. So I have my same example I did addition with you today. So let's get some line segments out so we can see this visually. Do two longer line segments, A and B, that look the same length. And then give me two smaller ones that look the same length, and we're going to throw C and D on there. Subtraction. Can you give me two pairs I can subtract? Give me a pair I can subtract that'll be equal to another pair. Figure out one pair I can subtract from each other that'll be equal to another pair. Okay, here we go. Boom, boom. Change the number real quick. 224. Okay, let's roll. 14. Of course, the only number I don't have. Perfect. Addie, can you give me two I can subtract? B minus, okay, fine. B minus D will be the same if you subtract what? I'll take line segment B, subtract D from it. I get a new one. What other two can I subtract that'll also be congruent to that new one? I got A and B are equal, C and D are equal, right? You took B minus D, fine. That'll be the same as subtracting what other two? A minus C. We're all good there. Okay, or give me another pair. Let's go, I'm going to challenge you today. Give me another pair I could subtract and still equal to each other. Jackson. B minus C is the same as, what was it? A minus D. There's subtraction for everyone now. There's subtraction. Let's use it using a diagram now. Go to example 1. Let's use it using a diagram. I want to show you how we're going bigger to smaller. And I let you guys off too easy writing the givens in for you. Okay. DAC. Look at the diagram. Look at the diagram, everyone. Go DAC for me in that order. What type of angle is that? That's a straight angle, right? It's how many degrees? A buck 80. Perfect. And it's equal to ECA because ECA is also a straight angle, 180 degrees. Okay, so everyone all right? I got DAC, ECA equal because they're both 180. 1 and 2 are equal. Mark it. Mark it. 1 and 2 are equal. Mark it on your diagram with the arc marks. And I'm asking you to prove what two angles are equal. 3 and 4. So now you got to take a look. Look at my givens. DAC, what type of angle was that? Straight angle. Look at angle 3. Is my angle getting bigger or smaller as I go from the givens to the proof? DAC to angle 3. Am I getting smaller or bigger? Smaller now. Yesterday I was getting bigger and using addition, but now the angle's getting smaller, so that's why I'm going to introduce subtraction today. Okay, that's when I use when my angle goes from bigger to smaller. Okay, but the rules still apply. How many quantities do you need to subtract? 2 pairs, right? Look at everyone. Look at your givens. How many are written in your givens? 2. So do you need to find a reflexive one on your own? No. We have everything we need in the givens to subtract. Are we okay? Why it's subtraction? Okay, so in statement 2, we are ready to subtract. We don't need a reflexive. So give me the 2 angles. I'm going to call on somebody here. The 2 angles you want to subtract to get to angle 3. So look in your givens. What 2 angles must I subtract in the givens from each other to get to angle 3? What are they? Always all the way over there. 7 spot. Ellen? Okay, well, I'm just going to slow down here. Angle DAC, the straight angle, what do I need to subtract from it to get angle 3?
1.
Angle 1. Good job. Good work. Everyone see how that's going to give me angle 3? Equal to, not angle 3, but equal to the other two angles you're going to subtract now to get to angle 4. 19. Zach? Angle EAC minus angle 2.
Oh, sorry. Yeah.
You're fine. What's wrong?
I said EAC, not EC.
Okay, I'm sorry, I didn't catch it. So, what's the reason? What did we just do to the angles? Subtraction. Yep. If you take DAC and subtract angle 1, let me do that. This is kind of corny visually, but ready? If you take angle DAC, I gotta go over here, and subtract angle 1. Bye-bye, angle 1. What's left? Angle 3. Yep. So step 3, angle 3 is equal to angle 4. Substitute it in. And we talked at homework. Look, right after you write subtraction or addition, better be ready to write in substitution. So did I do anything other than change addition to subtraction? It's an addition. It's the same steps. You just got to realize, am I getting bigger or smaller? Because on homework this weekend, I snuck an addition one in there on you. And see if you can recognize it. All right, how about this one? How many givens did I just provide you?
Only one.
Oh, yeah, something's got to ring in your head if I only provide one. All right, hold on. Yep, hold on. We'll get there. All right, but something's bell's got to go off in your mind if I only gave you a given and not 2. DF is congruent to BE. Now, if you do what you want to do to mark that congruent, here's what I do. I just do like a little bracket from D to F and a little bracket from B to E. And I put the hash marks on those. That's how I roll. You roll however you want, as long as you know they're congruent. And I'm asking you why segment DE is congruent to segment BF. Step back, ask yourself, from the givens to the proof statement, are the segments getting bigger or smaller?
Smaller.
Yeah, they're getting smaller. Everyone can see that. So if they're getting smaller, the only way I can do that is if I subtract something from them. All right, so this is going to be subtraction. But I know I can't do subtraction in step 2. Why not? Well, I need 2 pairs to subtract, and how many are in the givens?
1.
Only 1. So that next one's got to come from you. And yes, guys are right. It's a reflexive, but you got to find it in the diagram. What do you need to subtract from DF and BE to get smaller to DE and BF? Where is that reflexive? I need to subtract. Emma. EF. Everyone agree? EF. So there's your statement number 2. EF congruent to itself. Reflexive. It seems like some of you getting, I don't want to say comfortable, but we're moving there. How many pairs are written down now?
2.
Can you subtract now?
Yes.
Go ahead. Step 3. Tell me what you're subtracting. Now I got to hear from you guys. Relax. Lisa, why don't you tell me what you're going to subtract? Yep, is the same as subtracting what? Good work. And then hopefully here we know what's coming up, right? I subtract, I add, right after I got to substitute in what they're equal to. Any questions there? Going? Not bad? So we're all good with subtraction because I'm taking a little turn now away from addition and subtraction and going to something else. All right, we're going to spend some time here today. Here's our final one for today. It's called halves of equal quantities are equal. All right. I just want a visual before we start. Don't copy anything down. What do I know about my line segments? Okay, they're congruent. That's what I marked on there. That's what the hash marks mean. Okay. I'm going to take half of AB right now. Okay, I'm going to take half of AB. Sliced it in half. And I'm going to call it A. Anybody have a preference for a letter here? M, sure. I'm going to take CD. Cut it in half. And I'll call that C. Anybody got a preference? H, sure. What do I know? What should I know about AM and CH? The originals were congruent, and I just split them in half. What do I know about the halves? Are they congruent? Yeah. And if you guys don't believe me, let me put numbers on them. Maybe that'll help some of you. Let's say AB is 10, and CD must also be 10. How long's AM? And CH? Okay. So you guys see? If you take halves of what two things that are already equal, they're going to be equal. Okay, that's what this new one is saying. Halves of equal quantities are equal. Back there. All right, it says keywords up there. We have gone over 2 vocabulary words in Unit 1 that specifies something is going to be taken half of. That's your job right now. Can you remember those vocabulary terms? There's 2 vocabulary terms that when you see it, I think your mind goes, oh, something's being cut in half. I got two terms, 2 vocabulary terms. When you read them, oh, something's being cut in half on it. Romeo.
Bisector.
Bisector, yes. So if we see bisector in a given, we see the word bisector. That means probably going to use this new fact of halves of equal quantities are equal. Why? Why that one? Bisector means what? Something's being cut in half. And there's another vocabulary term which means half for us as well. Bisector and good job, midpoint. So if I see midpoint in a given, I'm thinking something's being cut in half. I may want to use this new reason. Okay, ready? I don't need a diagram for this example here. What do you know about AB and DC? They're congruent. They're equal to each other. What am I doing to AB? Read the next one. What am I doing to AB? I'm cutting it in half, right? That's what that means, half AB. And what am I doing to the other one, DC? Cut it in half. So what should I know about AF and EC then if I'm taking 2 equals and cutting them in half? Nick, what should I write in statement 2 then? What's true? AF is congruent to EC. And my reason is my new reason here, which says halves. What do you know about AB and DC? What do I know about AB and DC from the beginning? They're equal. So if I take halves of 2 equal quantities, they are equal. Halves of equal quantities are equal. But, ready? And it didn't I'll explain why it didn't happen here, but if you're going to use this, write it down, you need to make sure you have things above in your proof before you're allowed to write down this reason. Must-haves. You must have a pair of equal quantities. Did I have that already? What were they? AB equals DC. You must have that first. And you must tell me that you're taking half of them. Did I tell you we were taking half of the equal quantities? Yeah. So, guys, you're not going to be given all this information in a proof. You may have to write what you're taking half of. You may have to tell me what the equal quantities are. All right, I'm just letting you guys know that all of this will not be provided, very rarely. You're going to have to write some of this in yourself, including the final proof we're going to do today. There's our boy. Here's where we start raising the game right now. Goodbye, addition, subtraction, substitution. Read the givens real quick. What word pops up right away? Bisect. Ding, ding, ding. I don't know if you want to circle it, whatever, but that tells me, hey, I'm about to use somewhere, maybe not step 2, but somewhere in my proof, I'm about to use halves of equal quantities or equal. Somewhere in the proof. Maybe not step 2, but maybe down the line. All right, are you ready? What two angles are equal? Whoa, 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 whoa. From the givens. Read the givens, everybody. What pair of angles are equal from the givens? Just read it. DCB and DAB. Mark them. Mark them. Never say that again. Mark them. DCB and DAB. Those two right there are equal. Stop. Stop. Remember the must-haves you need for this? We already have the equal quantities, don't we? That's already given. Yeah, you're welcome. You're welcome. Thanks, Mr. Carlino. You're welcome. You already have that. What you don't have is a statement saying you're about to take half of them. All right? That's what we need to write in before we write halves of equal quantities. Name one angle that's being bisected. Name an angle that's being bisected. DCB. So we're about to take half of DCB. This is the half statements that are needed I was talking about. Half of DCB, and we're going to call that angle, well, now I'm in a predicament and I need your help. Everyone look at DCB. If you take half of DCB, you could call it DCA. Everyone see that? DCA. Or I could call it what? What's on the other side? S, right? I could call it half of DCB could be angle DCA, or it could be angle S. There's only one I care about, though, in this proof, out of those two. Look at the rest of the givens in the proof statement. Which one do I only care about? So I'm going to say it's equal to angle S. It is correct if you said it was equal to DCA, but that's not part of the proof. S is. Is there another angle you're going to take half of?
Yeah.
What is it? Okay, so tell me, I'm about to take half of angle DAB. And in this case, look at your diagram and what you're asked to prove. I'm going to say half of DAB is the same as angle. What is it? What is it? What are you guys? What are you guys? Pirates? Moving on. Set classes up every year with that one. All right, some of you have no idea what I'm talking about. That's a shame. Anybody know where pirates like to eat? Arby's. No, okay. All right, sorry. Yep. Favorite vacation spot? Argentina. Oh, come on, kids. Come on. Thought you were above average. Oh, you wanted one more? Yeah. What movies? What's your favorite movie? Yeah, my man. Not a favorite movie, but anything rated R. Yeah, good. Beautiful. I got a zillion of them. Half a DCB, half a DAB. Equals angle S and equals angle R. What would be my reason? Because I'm not ready for this yet. This isn't halves of equal quantities. Oh, there we go. How did you know we're going to take half of them? What word came up again? Bisect. Definition of a bisector. All right, let's go through our checklist before we write down halves of equal quantities. Ready? Do you have equal quantities written down? Where were they located? In the givens. Those were the two angles that were equal. Did we write down that we're taking half of them? Where was that in our proof? Second statement. We just wrote that, right? That we're taking half of them. So now we can put this together and say, what about angle S and R if I'm going to take half of DCB and DAB? They're congruent. Angle R congruent to angle S. Whoa, substitution. No. There's no duplicates up here. This is my reason. Jackson. It's halves. Look at what, guys, read what you did in step 2. You're taking halves of, what do you know about the angles you're taking halves of? They're equal. Halves of equal quantities, which we called R and S, are equal. It's no substitution, no addition, no nothing. Just halves of equal quantities are equal. So look out for bisector and midpoint tonight. Okay? And I snuck in an addition one on you there somewhere in the homework. Look at example 1. Because I know when I let you guys go on your own, like it just becomes a spaz show here for some of you. Just read the givens. What do you see in the givens? What do you see in the givens? Okay, yeah, you don't have to read, but what sticks out to you? Halves. You see halves, right? So probably what's going to be the reason here at the end? Halves of equal quantities. Ready? Ready? This is how you can tell how many steps this is going to have. Do you have equal quantities in the givens? Have you written down what you're taking half of? So you got both. How many steps is this going to be? 2. Second step's going to be those angles are equal because of halves of equal quantities. Do you see that? You need equal quantities, and you need to tell me what you're taking half of before you write down halves of equal quantities, and I gave you everything in the givens. All right? Just look at 2 quickly. Do you see the word midpoint bisects at all in number 2? Anybody see it? So you shouldn't be using what in the proof? Halves of equal quantities should not come up. So maybe it's in an addition or subtraction proof instead. Okay? The only time we're going to use halves of equal quantities are when I see bisector, midpoint, or like in number 1 where I just wrote out that they're half. Get after it. Let's go. Yes, it's getting tougher because the number of facts I